whenever you have almost 1 week, so we only cover like not more than 1 or 2 pages in each class. So 1 or 2 pages will take not more than half an hour to revise thoroughly. So please understand this thing that if you do not revise the physics, you are not going to score at all. Physics is all about the practice. Physics is you can say sibling of maths. If you leave the practice of maths, so you are not going to score at all. So please and please do start the revision. Do not say a bit or not at all. Completely revise the following topics that we have done so far. Because electricity is a very important chapter. If you talk about the numerical point of view, the electricity is the only chapter in which you can get easily tricked by the exam by the questions. The coming topic, that is combination of resistors, parallel series, both are very important and a little bit complex to understand. So if you are thinking that we can just go through the classes and all the things will be sorted, that's not going to happen. I've been continuously asking, please do the revision, but still not getting any kind of response from you, Vacho. So that is not the case. And most like Ayan and Ibadi have already joined in September. So I know you have scored well. That is a good thing. I'm not saying that that is like you are, but the thing is that even the good students require the revision. Doesn't matter whether you have scored full or not. It, revision is required by each student. Okay. So please do the revision whenever you enter the class. At least you should have given 30 minutes to the portion that we have covered in the previous class. So from now onwards, I'll be taking a viva. And if you do not revise, I'll basically convey it to your parents that students are not revising at all. Got it? So because that is the only thing that I can do right now because you are not listening to me. From now onwards, please do the revision and I'll take viva in the next class for the topics that we will be covering in this class, Ohm's law. Okay. So let's start the class. I think the students are not joining. Okay, so let's understand the Ohm's law. So in the last three classes, we have covered the electric charge. We have covered about the just a second. We have covered about the you can say the electric potential difference and the electric current. So these were the three fundamental quantities of the electricity chapter. Now we are going to combine them all and basically establish a relationship between the potential difference and the current. Is that clear, all of you? Okay. So Ohm's law. So basically, this is a law given by a scientist. Okay, so I'm not sure what was the name. Basically, the surname was Ohm's. Surname was of the scientist what was Ohm. So that's why it is called as Ohm's law in the name of the scientist, right? And basically, this laws establish a relationship between establish a relationship between the potential difference and the current. It tells you that how they are affected if we increase or decrease the values of the current and potential difference. Is that clear to all of you? Okay. So now let's understand. So in simple words, the statement of the Ohm's law is given as so Ohm's law says that the potential difference, or you can say the current flowing through a conductor, is directly proportional to the potential difference across its end at constant temperature. Let me write it over here. Razan, are you there? Please switch on your video.
Yes.
Directly proportional to the across seconds. And okay, so this is the statement of the Ohm's law. Is that clear to all of you? So it means that it says that V is directly proportional to the I. According to this statement, this is the thing at the constant temperature. I'll let you know that why it is at a constant temperature. Once we will do the resistance part, I will let you know about that. This is V. And if I remove this proportionality sign, everyone, so I will get a constant that is called R. That is the resistance of a substance. So resistance of a substance is a property of a substance basically which does not allow the electric charges to flow easily through that conductor. So yeah, I'll let you know. We'll just start the resistance part once we'll complete this. Is that clear to all of you so far? Please do let me know.
Yes, sir.
Yes.
Any doubt so far to you, Galvin, Gianna, Ibad,
No, sir.
Fezan, and Sumaya?
No, sir.
Fezan, please do switch on your video. I've asked something from you. So this is the next thing. Okay, now let's talk about that this R. Basically, this R, first point. So R is a constant called resistance. Fezan, am I audible to you? Okay, so this R is the constant called resistance. We'll let you know about it. Okay. And in terms of basically the R is the ratio of the potential difference and the conductor. Okay. So it means that if it's a constant, so if we change the current or potential difference, it will basically adjust accordingly so that the R remains constant. Is that clear? It means that the ratio will be constant. It's not going to change at all for the specific resistance that is given there in the problem or in the situation. Is that clear to all of you? Please do let me know.
Yes, sir.
Yes,
That's
sir.
it. Okay. So the R is called as a part. If we talk about the definition of resistance in terms of the current and the potential difference, the R is the ratio potential difference applied between ends of a conductor and the current flowing through it is called resistance. The ratio of the potential difference across the conductor and the current flowing through it is called the resistance. Is that clear to all of you? Do you have any doubts so far? Please do let me know, Mitchell. That's clear. So now everyone, as you can see this thing that here it is written as V is equals to IR. And if I basically want to take basically to find a relationship between the current and the resistor, that would be V by R, yes or no? The ratio of the potential difference and the resistance of the material. As you can see this thing from this, can I say that everyone? This is C part and C part of the first part. Can I say that current is directly proportional to the potential difference? That is, we have already discussed in the definition of Ohm's law. Is that clear? That the current is directly proportional to the potential differences. Okay. Just it's malfunctional. Hmm. The potential difference. Second point of this is the current is inversely proportional to the resistance. It means that higher the resistance of a material, lower will be the current flowing through it. That's why this property is the opposition property of a material. It means that current cannot flow easily if the substrate is providing high resistance. Is that clear to all of you? Please do let me know.
Yes, sir.
Okay? Current cannot be provided easily. Is that clear? Any doubt so far? Please do let me know. Okay? So, just a moment. Okay. The next is the current is inversely proportional to the resistance of a material. Okay? Is there any doubt so far to you, Bachu? Please do let me know. Okay. So now, okay. So next point is basically, so if you increase the current by double, the potential will increase or decrease? Do let me know. If you increase the current by the double, the potential will decrease or increase, or vice versa. If you do it vice versa, please do let me know. What will happen if we increase the potential difference? If we double the potential difference, what will happen to the current? What will be the effect on the current?
Increase.
Increase by what factor? If I'm saying double the potential difference, what will be the factor of the current if it's getting increased or decreased?
Double.
Double. What about rest of you? Ibad, Galvin, Gianna, and
Increase.
Nuha, Sumaya?
So it'll decrease by double.
Decreased. Okay, my Gianna. Yes, Ibad, you said something?
No, sir. So it will increase.
Increase. By what
Increase by
factor? Double. Acha, theek hai.
Double.
Ibad,
increase.
by what factor?
Double.
Double. Sumaya, Nuha, and Faizan. What will happen to the current if you increase the potential by double?
Increase by double.
Okay. Sumaya, are you there? Faizan, are you there? Nuha, Sumaya, and Faizan, please do switch on your videos. I cannot see your faces. So how would I know that whether you are attending the class properly or not? Please switch on your videos. It's a request to all of you. Whenever you enter the class, please switch on your video at first instance. Nuha, your screen is black. Please check your camera. So if the, as I've told you that the potential difference is directly proportional to the current, it means that the potential difference is getting doubled. So the effect on the current would be doubled. It will also get increased. Okay, Gianna, Galvin, Sumaya, and Faizan, Noha. Okay. So and everyone, this is a basic law, and this law will be getting repeated again and again in every type of question that we will do from now onwards. It will be basically applied in the combination of resistor. It will be applied in the Joule's law of heating. It will be applied in the power of a current. It will be applied to calculate the commercial unit of the current, electricity. So it's a request. Please understand this properly. If you have any doubt, do let me know. Okay. So that it is clear to all of you. Okay. It is doubled. Then the current will also get doubled. Okay. And similarly, if you half the potential difference, what will happen?
It will decrease
It will decrease by what factor, Ayan?
by half.
By half, yes. And if we double the resistance, what will happen to the current? Do let me know in the chat. If we double the resistance, what will happen to the current? And just analyze the equation that I've written in the part C. The answer. Okay. So is there only one student in the class? If I'm asking something, is there only one student? Okay, Faizan, chicken. What about rest of you? Do it fast. Just let me know the factor of the current by which it is getting decreased or increased. Okay, Bad. Okay, Gianna. Faizan.
Yes.
Okay, Faizan already did the answer. Faizan. Okay. Yeah. So the current is going to be half. If you double the resistance, the current will become half as they are inversely proportional to each other, right? That is a good thing that we have answered. So whenever I ask any question, always answer irrespective of the right and wrong. Okay, so you have to just answer so that at least I get to know that you are there in the class with an attentive mindset or not. Okay, if the resistance doubled, the current gets half. And if we decrease the resistance by half, what will happen? In the chat, let me know. If the resistance is decreased by a factor of half, what will happen to the current? Just a moment. Okay. Okay, Gianna. Oh, Ayan. Okay, Ayan. What about rest of you? Ibad and Galvin and yeah. Yes, Bacho, please do let me know. Okay, Ibad. The current will become double. Ayan, it is not increased by half, it will become double because
Sir, first I wrote half and then I said double.
okay, the 2 will go in the numerator now. So that's why it is 2 times. Okay, because this is a double division right there. Okay. So if the current gets half, if the resistance gets half, the current will increase by a factor 2. Okay. So now please do let me know, is there anyone who is having doubt till now?
So you wrote
Yes, Jan.
if the
Huh?
resistance is double the
Okay, sorry. The current gets half. Okay, current was missing. Yeah. Now, what happened? Do you have internet issue? Am I audible? Okay, now everyone, let's talk about the resistance property. Okay. So what basically a resistance is? Now we are going to understand the things about resistance. Actually, before that, just a second. Before that, let me give you a graph portion. graph of Ohm's law. This is a very important topic, everyone. Sometimes the MCQ comes in the exam that which of the following graph is the correct representation of Ohm's law. Okay. So this is the topic. Now the graph of Ohm's law. So it will draw the two graphs. So, this is graph. This is the second graph. Okay, so there are two types. So basically two graphs, not two graphs specifically, they are just basically inverse of each other. So first graph is basically a VI graph. V versus I graph. Okay. So this is V. Whenever we are saying V versus I graph, so first this is written as Y axis. This one is written as X axis. Is that clear to all of you? So current and potential are directly proportional to each other. So the line would be straight of the slope. So this is the thing that we have done in the ninth class as well in the motion chapter. When the motion is uniform, there is a straight line. So similarly, when the current is directly proportional, it means that they are dependent on each other linearly. That's why if you increase the value of current, the potential difference will increase and vice versa. It means, okay, is that clear? So that's why the slope of the Ohm's law of V versus I graph would be straight line. Is that clear to all of you? Please do let me know.
Yes, sir.
Okay. Now let's talk about the slope. So what do you, is there anyone who knows what is slope? You can tell me what do you mean by slope? Is there anyone? So this is slope. Is there anyone? Please let me know the formula of this slope. No one. Chalo, koi nahi, let me tell you. So slope is the ratio of y-axis to x-axis. Okay? Always remember it's the ratio of y-axis to x-axis. So y-axis is v, x-axis is I. So V by I is nothing but, can anybody tell me from the notes what is V by I? Yes, everyone. Can anybody tell me what is V by I from the notes?
So resistance.
Resistance. Very good, Gianna. That is resistance. It means that the slope of the VI graph will give you the resistance of a conductor. Okay? It means that increase the value of, it means that the higher the slope, the value of resistance will be higher, because higher the slope, the value of R would be higher. Okay, steeper the slope, the value of R would be higher. Is that clear? So from the graph, you can say that steeper the slope. Steeper means making the highest angle with the x-axis. Okay, steeper the slope, higher the value of the R. Please do let me know, everyone, is that clear to you or not?
Yes, it's clear.
Any doubt so far to anyone? Steeper the slope, higher the value of the R. But and in the second case, that is the second graph, that is your I versus V graph. basically the graph is changed, the axes are changed, or you can say the quantities are changed on the axis. Okay. So on y-axis now that is I, on x-axis that is v. Okay. This will also be a straight line because if I have told you that if the potential difference is directly proportional to the current, we can also say that in the reverse manner that the potential difference, current is directly proportional to the potential difference. Yes or no? If you increase the current, the potential difference will also get increased. Yes or no, everyone? Right.
Yes, sir.
So in this manner, this is again, it would be a slope that is basically your slope. Okay. Okay. Similarly here, the slope would be equals to y-axis to x-axis. Now on y-axis right now, I is there. So it would be I divided by v. So it will be reverse of it. So that is x-axis. So that is I by v. So now if we basically see this thing, if we are getting v by I as r, so if we take the inverse of it, so we will get 1 by r. If I get I by v as the ratio, yes or no, everyone? Yes or no? From this equation only, if I basically remove it, see this thing, if I basically see, can I write this thing as, I need the value I by v. So I will take r on this side and v on this side. So I'll get ultimately 1 by r is equals to I by v. Yes or no, everyone? Please do let me know.
Yes, sir.
Okay. Any doubt so far to anyone? Is there anyone who is having doubt? Please do let me know. No doubt to anyone? चलो ठीक है. ठीक है. So as you can see, I'm getting I by V as 1 by R. So it means that in this graph, if we increase the slope, lower will be the value of resistance because we are taking the 1 by R inverse of resistance. If we increase the value, if this is getting increasing, ultimately the fraction is getting smaller. Is that clear? So steeper the slope, lower will be the okay. So that's when in basically these types of questions, student gets confused that they think only VI, they know only VI graph, but they do not know the IV graph, that is the inverse of it. So that's why they answer these types of question in a wrong manner. Is that clear? Any doubt so far to anyone? Please do let me know.
Yes.
So that's great. Okay. Now let's talk about the resistance. So in this, we are going to talk about the resistance. So if we talk about the resistance as a property of a substance, so resistance is a property of a substance that does not allow or that opposes the flow of electric charge through that wire or that conductor. Resistance is a property of a conductor that opposes the flow of charges through it. Is that clear? It's like a friction. When the electrons flow through it, the material, the conductor provides a friction for the flow of electron. Okay. So that's why this is a kind of, you can say, friction property in the metal wire in a conductor. Is that clear?
Yes, sir.
चलो that's good. ठीक है. Due to which opposes flow of flow of current. It is so every conductor provides some resistance to the current. Okay, it is not like a current flows like a very slippery, like for a current flows like without any problem. Yeah, but every material has different resistance value. Okay. So we'll discuss about the resistance once we will talk about the factors affecting the resistance in the next class. In this class, we are going to discuss about the properties. Okay. So in simple words, the resistance depend upon the length, thickness, nature of material, and the temperature. So that's why in Ohm's law, the statement says that at constant temperature, because if the temperature is not constant, is not basically it's not the same throughout the experiment, the value of the Ohm's law will be different. The experiment performed under the basically for the Ohm's law will not be accurate. So that's why resistance value in the Ohm's law experiment will not be accurate. Okay. So that's why it is said that the temperature should be constant in the Ohm's law statement. Is that clear? Whenever we are talking about Ohm's law, it should be performed at constant temperature so that the value of R should not get changed because R depends on temperature. Please do let me know, everyone. Is there anyone who is having doubt till now? Ibad, Gianna, Ayan, Galvin, Nuha, Fazan. It seems like only 4 students are there. Any doubt so far to anyone?
Yes, sir.
Chalo, that's it. Okay.
Yes,
So
sir.
we'll talk about in detail in the next class about the factors affecting the resistance. Right now, we are just doing a overview of this thing. Okay. The resistance, tension length, thickness, nature of material, and temperature. of the conductor. So these are the some factors that affects the resistance. Please do let me know. Is there anyone who is having doubt till now? Okay, and the next point about the resistance is everyone that SI unit of resistance is ohms. And it is represented by a symbol called omega. It is a Greek symbol. Okay, it is called omega. Please do let me know, everyone. Any doubt so far to you?
No.
Sure.
Yes, sir.
Okay, that's great. Now in this in the exam, sometimes the question for 1 marks appears like that define 1 ohm. So how to define that thing? Just like we have defined the 1 volt, 1 ampere, right? 1 coulomb. So we can also define the 1 ohm in terms of resistance, oh, sorry, in terms of current and the potential difference. Now let's define it. Please do let me know when you are done with the portion. Is there anyone who is still writing? Done, everyone? Chalo, that's good.
Yes.
So the 1 ohm can be defined as one ohm is the resistance of a conductor such that when a potential difference of 1 volt is applied to its ends, okay, a current of 1 ampere flows through it. Okay, so 1 ohm is defined as the when the potential difference is applied and 1 ohm of current is flowing through 1 ampere of current is flowing through it. A current of 1 ampere flows through it. Please do let me know, everyone. Do you have any doubt so far to you?
No, sir.
Sure. Okay, so let's do a basic question because right now we don't have that much time. So let's do a basic question that basically helps you to understand the implementation of the Ohm's law statement. And in the next class, we will be doing the question based on the Ohm's law, and we'll understand the factors affecting the resistance as well. That what are the factors and how basically how does it affect. As you can see, question says that potential difference between 2 points of a wire carrying 2 ampere current. So the current is basically 2 ampere and voltage is 0.1 volt. Okay. We need to calculate the resistance of a circuit. Okay. So I need to calculate the R. So that is simply according to Ohm's law. V is equals to IR. Okay. So R we need to calculate. So R is nothing but the ratio of V and I. So V is 0.1 and divided by 2. Okay. So R would be 0.05 ohms. This is your answer. Please do let me know, everyone. Is it clear to you or not? Any doubts so far, Twain? Please do let
Yes, sir.
Gianna, Galvin, Ayan, and Ivar. That's good. Okay. So in the next class, we will be doing the question based on the Ohm's law, and after that, we will be doing some more questions on the graphs of the Ohm's law, right? So that will help you to understand how to basically uh, understand and analyze the questions of the graphs in the exams. Okay. Okay. So okay, so in this class, let's keep it right here. So there is no assessment after this class, everyone. Okay, but it's a request from to all of you that please and please do the revision whenever you enter the class. At least give half an hour, 30 minutes to the topics that we have already done in the previous class, because that will help you to understand the next topic properly. Because if you do not revise, the next topic will be just completely will be, like you can say, you will get understand, but in the long term you will not able to understand it, you will not able to remember it properly. Okay.